Hey guys, I want to just get a hold of you and have a quick discussion on our 1.5 by 1 3/4 deep socket project we're going to be testing out next Thursday. Here's the drills that we discussed before the gold twists. Real quick before you start, I just want to throw it out in this so we remember. One, are we allowed to mess with that diameter in the corners on this so we can actually lower this scallop that I want to try to lower? So I did open the drill up to 2913 diameter. I don't know if that's acceptable, so we're looking at that. And then also, what's the max RPMs on the spindle? If we don't get the RPMs, you get some deflection with the small feed mills. So I want to see if we can at least get 6,000 and make sure that diameter is acceptable. That's all good. Going to go with the 1/2 times the gold twist drill. And at the pilot it, we have 4 of them off the shelf. Then the 8 times D. We do have them on the international, so we might not have it for the test next week, but we can use another drill just to test out the feed mill and the finished mill. And obviously the insert that I discussed at the diameter. Female I'm looking to rough that out with is actually our 4 flute 8mm high feed mill that we can take about 10 thou depths on cut and then 20 thou per tooth, and you'll be spinning about 6,000 RPMs. That's 240 inches a minute, which I know we'll never get up to at the short distances in the machine acceleration deck. But that's why all the times that we're going to take with this project can be a grain of salt. It's going to probably be doubled, but we'll go over that. The finishing tool, I'd like to use a 6 fluter with 100. There's a 200 thou max step down, but do a 50% overlap. It's a 100 thou depth of cut. We'll just take a light skinner, try to leave only 3 or 5 thou, and skin it off with that guy for finish. And this is one product that I would recommend the heavy metal shank because we get so much deflection, you'll snap carbide and have issues, and you can't get the reach with steel. So let's get into it. Looking at the project, we'll do, like we said, we'll do the pilot process. We're going to drill about 300 thou deep. When you start up the longer drill, you want to actually only spin like 100 RPMs and like 10 inches a minute to get it in the hole. Then we can kick it up and go to same feed rate, same RPMs. And then there's the actual female rougher. So like I said, I don't know how it's going to drive in the corners, what to watch chatter, and then how much deflection we're going to get here. Since you're leaving small amount of stock, sometimes you get a little bit more deflection if you don't get the diameter engagement on these. We could even play with even leaving a little bit more stock. Sometimes I know this makes sense. In there, you'll get less deflection, but we won't know until we start getting into and do some testing and see what we can do. Right, wouldn't even be a bad idea just get a scrap on just in case something happens. Another thing we have to watch is when you're breaking on the other side, you have this thin burr here. Usually female, you'll push down, it'll just push that burr down, and then once it goes through, it'll just break off the burr. So we'll have to watch that too while we're running it. And then obviously the finish tool with 100 thou step down. Looking at the CAM software, they're only saying that the entire process is only going to be 5 minutes, 53 seconds. I know it's not going to be that short with the acceleration decks and the cutting and everything. So probably double that. I'd like to try to get around 10 minutes as long as we can deal with that burr and get everything good there. I think that's achievable. So any questions we can discuss next week. We'll get tools on order. If we don't have those drills, we'll have to use what you have in the shop. I don't think that's going to be a problem. So if you have any questions, we'll wait till next week. We'll finish discussion then. Thanks, guys.